Yeah, okay. So good morning. Now we shall start today. Okay. Write down pneumatic system mathematical model. Okay. Right. Write down for the following pneumatic system. For the following pneumatic system, derive an expression. Derive an expression to relate. To relate to relate how the pressure in the bellows, how the pressure in the bellows P2, how the pressure in the bellows P2 varies with time. How the pressure in the bellows P2 varies with time when there is an input pressure P1. When there is input pressure P1. When there is input pressure P1. Also describe how the extension or contraction, how the extension or contraction x, you write quotes x of the bellows, changes with time when there is a input pressure P1. When there is a input pressure P1. When there is a input pressure P1. Okay, right. So now please observe here. Okay, I'll just give the diagram later. Just observe the question. Okay, first of all, now here there are two derivations which have been mixed here. Okay, in the first derivation, basically you have to describe how the pressure in the bellows. Okay, P2 is pressure in the bellows. Okay, so how the pressure in the bellows varies with what? Varies with input pressure. Okay, varies with input pressure P1. Okay, so this is one derivation. Okay, and there is a continuation of this derivation to show how the extension or contraction, anything extension or contraction, it is nothing but deflection. It is x of the bellows varies with input pressure P1. Okay, so these are the two derivations which are going to be there. Now, what is the hydraulic element that we need? Sorry, what is the pneumatic element that we need to consider here? What is the pneumatic element? The pneumatic element. Hello, are you listening?
Bellows,
the pneumatic element is the bellows. Okay, bellows is a pneumatic element. What is this bellows actually? What is this bellows means?
Sir, it's a type of pressure controller, sir.
Okay, it's a type of pressure measuring device. Okay, it's a pressure controller and which is used to measure the pressure. Okay, when it is going to contrast. Okay, right. Now we'll just now with this introduction, we'll start with the diagram. Okay, please take this diagram. Over. Over.
Yes, sir.
Okay, right. Now this is the bellows. Okay, observe, this is the bellows. Now P1 is the inlet pressure. P2 is the pressure within the bellows. Okay. Now this is nothing but a orifice. Okay. So this is nothing but what is called as the constriction. Okay, or the orifice. Okay. Right. What do you mean by constriction means? Any idea? Constriction is nothing but what? What it gives you? What this constriction?
Sir, it is a change in cross section wherein it provides for a resistance for the flow, sir.
Yeah. Okay. Constriction is nothing but an abstraction. Let us put in a simplest way. Constriction is nothing but an abstraction where some change in cross section is going to be there. So whenever there is a change in cross section for the air to move, okay, so the pressure and the velocity is going to change. Okay. So this constriction will gives you what basically this constriction will gives you the resistance to the flow. Okay. So one type of the basic building block is the resistance. Okay. The other one is what? The bellows. Okay. Now the bellows is going to give you what is called as the capacitance. Capacitance is nothing but what? The air carrier or the storage. Okay, is going to be given by the capacitance. Right. Now just write those two, resistance and capacitance. Then we'll go further. Okay. Right. Don't worry about this line. Okay. Right. Okay. Over. Then what is the amount of mass entering here is m dot. That is the rate of mass entering is m dot. Okay. M dot is nothing but dm by dt. It is rate of change of mass with respect to time. M dot. Okay. Write down. Bellows is an example of a simple pneumatic system. Bellows is an example of a simple pneumatic system. Bellows is an example of a simple pneumatic system. The resistance is provided by a constriction. Resistance is provided by a constriction which restricts the rate of flow of air into the bellows, which restricts the rate of flow of air into the bellows, and capacitance is provided by the bellows itself. Capacitance is provided by the bellows itself. Okay. Right. Now, okay, just observe. Okay, now we know that the constriction will gives what is called as the resistance. Okay, and bellows will gives you the capacitance. Okay. Now we'll write the equation. Okay, for the resistance, and we'll write the equation for the capacitance. Okay. So from where are we going to write this equation? Is from the basic building block equation. Okay, now if you remember last class we had done this basic building blocks, correct? Now basic building blocks equation. Okay, that is what basic building blocks equation for the hydraulic resistance, sorry, the pneumatic resistance, pneumatic capacitance, and pneumatic inertance we have done. From that we'll take the equation and we'll try to relate, okay, this point number 1 and point number 2. Okay, right. Now we'll start with the resistance. Okay, now in the resistance the flow is for what? Okay, so it is against the mass of the air or the mass of the gas is entering. Okay, I am restricting what? I am restricting the rate at which the mass enters. I am restricting the rate at which the mass enters into the bellows. Okay, right. Next you write down now. Now you write the mass flow rate. The mass flow rate into the bellows. The mass flow rate into the bellows is given by the mass flow rate into the bellows. The mass flow rate into the bellows is given by the mass flow rate into the bellows is given by P1 minus P2 is equal to Rm dot. Rm dot, where P1 is equal to pressure prior to the constriction. P2 is equal to pressure after the constriction. Okay, that is where this is the pressure where within the pressure after the constriction is nothing but pressure within the pressure within what element? After the constriction, what you have? What element you have?
Bellows.
Okay, so after the constriction, you have the bellows. That is nothing but pressure within the bellows. Okay, right. Now, we'll write, this is about the resistance equation. Okay, next we'll write the capacitance equation. Okay, now to write the capacitance equation, the mass which is enters into the bellows, will it goes out of the bellow?
No, sir.
Okay, so it is going to be present in the bellow. What it does, it reduces or it contracts the bellows. Correct or what? The pressure, the mass rate which is enters into the bellows will contract the bellows, and there is no possibility for the gas to escape out of the bellows. Okay, right. That will write. Next line you write. All the gas that flows into the bellows, all the gas that flows into the bellows, all the gas that flows into the bellows remains in the bellows, there being no exit, from the bellows, there being no exit from the bellows, there being no exit from the bellows, there being no exit from the bellows. Next line you read. The capacitance of the bellows is given by 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 M1 dot minus M2 dot. Okay, M1 dot minus M2 dot. is equal to C1 plus C2. This is the capacitance equation. C1 plus C2 into dP2 by dt. dP2 by dt. Okay. Next line, you write. Next line. The mass flow rate entering the bellows. The mass flow rate entering the bellows is m1 dot that is equal to m, that will be equal to what? P1 minus P2 by R. P1 minus P2 by R, which is given by resistance equation. Which is given by resistance equation. And the mass flow rate leaving the bellows, and the mass flow rate leaving the bellows equal to m2 dash. That will be equal to what? What is the mass flow rate leaving the bellows? What is the mass flow rate leaving the bellows? How much? How much mass flow rate which leaves the bellows? Hello? Are you all connected?
Yes, sir.
Okay, what is the mass
Yes, sir.
flow rate leaving the bellows? 0. Okay, so no mass will go out of the bellows. Everything is going to be present within the bellows only. So m2 dash is equal to 0. Okay, so now the above equation is going to become what? So this equation, okay, that is m1 dot minus m2 dot is equal to C1 plus C2 divided by dP2 by d2. So m2 is equal to 0 now. Okay, m2 is equal to 0. m2 dot is equal to 0. m1 dot is equal to what? m1 dot is equal to m. Okay, that will be equal to p1 minus p2 divided by r. Okay, so next line you write. Next page I am going now. Okay, right. So it becomes m1 dot. Okay, so directly we'll write m1 dot. m1 dot will be equal to what? P1 minus P2 by R. Okay, that will be equal to what? C1 plus C2 into dP2 by dt. Okay, so rearranging P1 minus P2 is equal to R C1 plus C2 dP2 by dt. Okay, right. So therefore we'll write P1 is equal to R into C1 plus C2. Okay, plus P2. P1 is equal to R into C1 plus C2 dP2 divided by dt, dP2 by dt plus P2. Okay, right. Have you noted down here? Have you noted down?
Yes, sir.
Okay, now what is this?
Yes, sir.
What is this equation? This equation describes how the pressure in the bellows. What is the pressure in the bellows? P2 varies with inlet pressure. Varies with inlet pressure P1. Varies with inlet pressure P1. Varies with inlet pressure P1. Okay. Okay, right. So this is one type of equation. Okay, one set. Okay, I wrote now 1 and 2. Okay. So now second one will write. Is it clear up till here?
Yes, sir.
Okay, right. Next, second one is I need to relate what? I need to relate with how the contraction X of the bellows varies with pressure P1. Okay, so now why the contraction is going to come now? Why the contraction is going to come? Because of what? Because of what the contraction is going to occur? Why the bellows is going to contract? Hello? Why the bellows will contract?
Sir, because of vacuum, sir.
Because of
Vacuum creation, sir.
that's true. Okay, no, just because of vacuum the bellows will contract. No, in order to contract, what should be there? What will make the bellows to contract? No, which results? Vacuum is going to be there, fine. Okay, vacuum is there, the air will not go. What is that? No, there is what coming inside. There is what coming inside to the bellows. Pressure, exactly. Okay, the pressure is going to come inside the bellows. That pressure will within the vacuum. Okay, vacuum is going to be present in the bellows. Okay, within the presence of the vacuum, that pressure will what? Will contract the bellows. Now, how much will contract? Okay, depending upon the amount of contraction, you will measure what is the pressure which is applied. Okay, so when it contracts, what is going to happen? The contraction of the bellows is going to occur. The bellows will fold. Are you understanding? When it fold, I am going to call that as what? X. X is nothing but what is X actually? X is nothing but what is X? X is what? X is the deflection. Okay, deflection of the bellows. Are you understanding?
Contraction.
X is the deflection or the amount of contraction because of the pressure. Okay, below that you write the bellows expands or contracts. The bellows expands or contracts as a result of the bellows expands or contracts as a result of pressure changes. As a result of pressure changes. Full stop. Bellows is a form of spring. Bellows is a form of spring. Bellows is a form of spring, and hence F is equal to K into X, where X is the amount of contraction. X is the amount of contraction. Okay. X is the amount of contraction. Okay. But below that, right? But force F depends on force F depends on the pressure P2. Okay. What is P2 will be equal to? That is P2 will be equal to in terms of pressure. What is the equation of pressure with F by A? where A is what? Where A is the, where A is what? Cross-sectional area of what?
Bellows, sir.
Bellows. Cross-sectional area of bellows. Okay, right. Therefore, P2 into A is equal to what? F. That will be equal to what? P2 into A is equal to F. In turn, F is equal to K into X. Is equal to K into X. Okay. Therefore, P2 is equal to, okay, P2 is equal to K by A into X. Is it not? P2 is equal to K by A into X. Okay. Substitute the value of P2. Substitute the value of P2 in this we call it as equation 1. In the equation 1. Okay. P1 is equal to R into C1 plus C2. Okay. dP2 by T. P2 is equal to K by A into X. K by A is constant. Okay. dx by dt. Correct. Plus P2 is equal to K by A into X. Okay. K by A into X. This equation describes what? Describes how the contraction X of the bellows. How the contraction X of the bellows changes with time. Changes with time when there is an input, when there is a pressure P1. When there is a pressure P1. Clear now? Okay. There is a pressure P1. There is a pressure P1. Okay. Any idea? Clear? Any doubts? Clear? Have you noted down? Have you noted down? Over. Okay, right. So this is about the pneumatic system. Now here, remember, in pneumatic system, two parts are there. Okay. First part is basic building block. Okay. First part is basic building blocks. Okay. How many? So three basic building blocks. Okay. Then second one is going to be mathematical model. Okay. Okay. Is it clear? Okay. So one example we took, that is the example of the bellows. This is what is the case of pneumatic system. Is it clear now? Clear?
Yes, sir.
Okay. So my voice is audible today?
Yes, sir. It's audible, sir.
Okay, fine. Now, in every system, what we discuss first? In every system, we discuss the basic building block first, and then the mathematical model. Okay, right. Now, we shall move on to the last one. Okay, we shall move on to the last building block. Now, what is the last building block expected? Can you guess? What is the last one? Thermal. Okay, now you have discussed about mechanical, electrical, hydraulic, pneumatic. Last one is, note down, thermal system building blocks. Thermal system building blocks. Okay. Now in thermal system building blocks, we have only two types of basic building blocks are there. Okay, so these are called as, the basic building blocks are called as thermal resistance. Okay, write down thermal resistance and thermal capacitance. Thermal resistance, thermal capacitance. Okay, so these are the two cases. Okay, right. Now, one by one, which let us discuss. Okay, right. Now, thermal resistance means what? What is by thermal resistance? Resistance for what? Resistance for
Temperature, sir.
temperature flow, or resistance for heat flow. Okay, correct. Resistance for heat flow. Okay, when the heat is going to flow, when there will be a flow of heat.
Is the difference of temperature between the two
Okay,
points?
when there is a difference of temperature between the two bodies, there the value of heat transfer will come into picture, that is Q. Okay, right. So T2 minus T1, okay, is required for what? For Q to occur. Okay, for Q to occur. Okay, for Q to occur, what should be there? Temperature difference should be there. Correct? No? Okay. If there is something which opposes this flow, if something which is going to oppose this flow, that is called here the
heat flow.
thermal resistance. Okay. So heat flow is going to be affected by what is called thermal resistance. Simple. Okay. Right now, thermal resistance. Take the heading of thermal resistance. There is a net flow of heat between. There is a net flow of heat between 2 points. There will be a net, please write like this, there will be a flow of heat, between 2 points, if there is a temperature difference, if there is a temperature difference, okay. If Q is the rate of flow or heat flow rate, if Q is the heat flow rate, and T2 minus T1 is the temperature difference, and T2 minus T1 is the temperature difference, then thermal resistance R will be equal to T2 minus T1 divided by Q. Thermal resistance R will be equal to T2 minus divided by Q. Okay, right. Next line. This value of R depends on the mode of heat transfer. This value of R depends on mode of heat transfer. Okay. For conduction, what is Q? Any idea? Anybody can able to remember the conduction equation, the heat equation, the heat flow equation for conduction? Q is equal to Ka T2 minus T1 divided by N. Okay. Okay. Correct? Where?
Yes, sir.
Where K is what? Can you guess? K is quickly. Let's finish this. K is thermal conductivity. Thermal conductivity. A is cross-sectional area. Okay. L is the length. Okay. Now, what is the equation for Q? From this, what is the equation for Q? Okay, what is Q? Q is equal to, tell me, Q is equal to what? T2? Tell me.
Minus
T1 by T2 minus T1 by R.
Correct? Okay. Therefore, R for conduction is what? Compare both the equation. R for conduction, this equation and this equation. Okay. R for conduction Q, T2 by T1 into L. T2 by T1. Okay. Right. What is R now? R is equal to this one itself. Okay. T2 minus T1. Okay. Divided by L by Ka. Are you understanding? Okay. Q is equal to T2 minus T1 by L by Ka. What is Q? T2 minus T1 divided by R. Therefore, what is R? R for conduction is equal to what? What, yeah? L by K into A. Okay. R for conduction is R is equal to L by K into A. Okay. Right. Then this is for conduction. For convection, what is Q? What is Q for convection? Any idea? H into A into T2 minus T1. Okay, H into A, T2 minus T1. Okay, where H is the coefficient of heat transfer, H is the coefficient of heat transfer, A is the surface area. Okay, now this you rearrange. Okay, now rearrange, we'll write Q is equal to T2 minus T1 divided by 1 by HA. Correct? Yes or no? Yes or no? Okay.
Yes, sir.
So what is the standard equation for Q with respect to R? We know Q is equal to T2 minus T1 by R. Correct? Okay. Therefore, R for convection is, what is R?
1 by H.
R for convection, R is equal to 1 by H into A. 1 by H into A. Okay. R is equal to 1 by HA. Okay. Is it clear? Okay. So this is with respect to the thermal resistance. Okay. Next, you take over. Have you noted down this?
Yes, sir.
Okay. Right. Next, you take the heading as, next page, as thermal capacitance. Thermal capacitance. Okay. Right. Okay. Write down. Thermal capacitance is a measure of the internal energy stored in a system. Is a measure of internal energy stored in a system. Okay. So what is internal energy stored in a system? What do you mean by internal energy stored in a system? Some energy enters into the system, some energy leaves out of the system. So internal energy is nothing but the difference between the energy enters into the system and energy flows out of the system. Okay, write down. If the rate of flow, rate of flow of heat into the system is equal to Q1. Rate of flow of heat out of the system is equal to Q2. Q1, Q2. Then, therefore, rate of change of internal energy. Rate of change of internal energy will be equal to Q1 minus Q2. Okay. Right. Next. What is Q1 internal energy change? We know that internal energy is equal to MC into delta T. Okay, this is the basic expression. MC into delta T is change in temperature. Okay, MC into delta T, where M is equal to mass, C is equal to specific heat capacity. Okay, specific heat capacity. Therefore, internal energy is nothing but Q1 minus Q2. That will be equal to M into C. Delta T is nothing but dt by dt. Okay, right. So this, the whole thing will replace by another constant. Q1 minus Q2 will be equal to C, capital C, dt by dt, where C is equal to thermal capacitance. That will be equal to M into C. Clear now? Okay, right.
Yes, sir.
Now this is about the thermal building blocks. Okay, so two thermal building blocks. Okay, one is your R. R is Q1, sorry, T2 minus T1 by R. This is one expression. Okay, so another one is, okay, C is equal to Q1 minus Q2 divided by dt by dt. Okay, so this is about the thermal resistance and this is about thermal capacitance. Okay, now by using this equation we are going to build up a mathematical model. Okay, so that we'll take it in the next class. Okay, so it is again I am telling, so in each of the system, first you are going to understand the basic building block. Second one, you are going to understand about the mathematical model. Okay, mathematical model. Okay, by using the basic building blocks. Okay, right. Now we shall stop at this stage. How many of you are there? All of you are there. Dhanush, Mithun, Mohanambal, Arsha, Sandesh, Sukrat. So Srinidhi is not there. Okay, okay, right. Okay, right. So shall we close it off?
Yes, sir.
Yeah. Okay, right.
Yes.
Oh, thank you.
Thank you, sir.
Thank you.